Unfortunately, reality doesn't work like that. So that's my Twitter. I've got a blog with a few stuff on it. That's the Simple Flat Mapper is my project, and I've got another project I'm really proud. It's Noob Factory. It's inspired by the JavaScript Noob library. So if you want to do no-ops, it generates no-ops for you. That's brilliant. Okay, so why do I talk about Java 9? First of all, Simple Flat Mapper has been working on Java 9 since August 2016 on the early access build. Also wrote one article for SidePoint just before it closed down, not SidePoint closed down, but the Java channel closed down, which reminded me at the time when I worked for Lehman Brothers and they went bankrupt. That was a joke. And I spent too much time following people on Twitter, so there you go. So Java 9 is available on early access. That's the URL there. There's still some change happening at the minute. The last one was proposed on the 5th of June. It's all mainly related to the Jigsaw on module integration. But apart from Jigsaw, everything is very stable. So I would advise to go and download it. And why do you care? Because Java is going to be end of life, and the line you care about is the one in bold, which is 1 year after the GA of a subsequent major release, which will be 1 year after the official release of Java 9. So that was the schedule 2 weeks ago, I think. So the GA was planned for July 27th. Originally, Java 9 was scheduled for September 2016. But no, it's been changed, and the GA is going to be the 31st of September. I didn't have to get a new screenshot. They changed it on the website, so there you go. Why the delay? Because of Jigsaw. So Jigsaw is a project that started in October 2006, so that's about 11 years now. And they were targeting JDK 7 at the time, and they didn't meet the target for JDK 7 or JDK 8, so it's been a long time. So why do we need Jigsaw? Why do we need a Java Platform Model System? That's what JPMS stands for. What's the model system about, and why did it take 11 years to do? That's you can do it in a week, mate. Kind of thing. So Jigsaw main reason is there's a big security issue. Right now in Java, you can go through encapsulation anytime with reflection. That's used, like, for example, with Hibernate to set your field or Spring to do field injection. But that's got a cost, and there's studies that show that 3 out of 5 0 days since JDK 7 would have been prevented with a strong encapsulation. There's some scalability issue too. Each deployment that is built with the full VM is very big, and Jigsaw allows to distribute do a build with only the necessary module, which will be very small. I think they're talking about a few megs or something like that. So, and another advantage of having Jigsaw is that you get compile time and start time check of your dependencies. So if you say you require a module, and the module is not present on your module path, it won't compile and it won't start up, which is great. So what's a module? Module is basically a jar with a module info class. So it's not exactly true because you can have multiple modules in a jar, but for most people that kind of use a Maven module style, they're probably going to map one module per jar. And it's that module info, which is written in Java and get compiled in bytecode. You specify what module you required, what module you're exporting, what services you're exporting, and what services are you using. There is no version information at the minute, and if you got a module info in your jar, but you put the jar in the class path, then it's not a module, it's a jar. So you can still use jar in a non-module way, which we'll see what that gives us. A module, one of the biggest things you have is reflection restriction to enforce encapsulation. So you can't call set accessible on private field, so you won't be able to do all the trickery that we were able to do, which obviously annoy a lot of people, like Hibernate or Spring or things like that. But if you declare your module to be open, then it is possible to use reflection to change those fields. So you can do what's called illegal access if your module is open. You can still, for reflection, reflect on a class that is not exported via by the module, but you can't do set accessible. That doesn't apply to ClassPass jars. It used to. They changed that very recently. So there's a flag that is on the VM, which is --illegal access, would tell, do I permit it? Do I put a warning, or do I deny it? And it's going to be permit by default right now, which is going to print a warning at startup and tell you that something is doing some illegal access, and but still run. Which means that a lot of frameworks that were not able to start without without some command line change to make it other stuff open will be working by default. The reasoning behind that is that they want, in a major version change, they want to warm so they want to break it. They want to warm first, and then they will change the default settings so that it breaks. No, I would strongly advise to run with illegal access denied, otherwise we are kind of missing all the security benefits from Jigsaw. But it'll probably be denied anyway in Java 10, whenever that's coming. So why did it take so long? So that's the graph, and I'm sure you can't see very much on it, but that's all the modules that are in the JDK or Java SE at the minute. And because you don't have access to other module unless you declare a specific dependency to it, they had to review all the code that was in Java SE and make sure that they didn't have unnecessary dependency, which some of them had. I believe that in the JavaNet package, there was some reference to Java AWT. For those who don't know Java AWT, it was the first API to do Java user interface. So yeah, it took 11 years. That's a big refactoring. Why is it being delayed now? There's kind of two major groups of concern. One was the migration route, which is reflection access. So if you were to start Java 9 and the reflection access were not permitted, so there was a big debate about that. Not accessible, but if you were to start, a lot of framework would have failed and require some command line modification. So on the command line, you can open a module specifically, or you can give access to packages, private packages on the command line to another module. So people would have to do that. But now that reflection is permitted, that's not a problem anymore. There was also a big debate about the naming of what's called automatic module. Automatic module is there to allow people to migrate to the module strategy with jars that are not modular anymore, and it was giving them a module name that was based on the jar. People didn't really like that, so now they added the possibility to add a module name in the meta-inf properties, and everybody is happy. There's some meta-module concern which are more involve framework like OSGI or JBoss modular system. They want to be able to do a lot more with Jigsaw than what it allows now, and those are probably not going to be addressed from question of time, and also because it's outside the scope of the JEP at the minute. So the one was allowing cyclic dependencies. They might change that later if a lot of people complain, but cyclic dependencies are not a good thing. Version is not going to be supported. The reasoning behind the version is that it's very difficult to solve the version problem. And by very difficult is that there's no way to systematically solve the version problem. And one way or another, at some point, if you want to support multiple versions, what you're going to have to do is shed. So if you got a library that needs a specific version, you shed it so you incorporate it in your jar. Otherwise, there's no strategy to actually solve the problem. So they're just ignoring the version, also because that did cost a lot of CPU time on startup. So like one of the version problems you could see is like, for example, Guava is not binary compatible. So if you depend on Guava 18, you might not be able to run against Guava 21. And there's, interface boundaries that would cause issue if you exchange Guava list or immutable list between different modules. Those concerns, though, doesn't stop OSGI or JBoss module from working. It just stops them from leveraging the JPMS. So they can still allow cyclic dependencies by having their own class loader, and they can all. What they wanted to do is be able to access an internal API to dynamically change a module. They can still do that with the class loader. So it's not going to be addressed. As an end user, what you should be concerned about. So no, you don't really are concerned about reflection anymore, because that's going to be permitted. But what you should be careful is, are you using any SunMISC API? That's really the only thing that matters. For example, the SunMISC base 64 decoder is not, most of them have been moved to new packages, and they are not accessible. They won't be accessible. The only thing that are still there because there's no replacement for them are the one described there, and especially the SunMISC on Ceph is still there. There's replacement API, but it's not covering everything. One is called variables that we'll cover a bit later, that allows granular memory access. But there's other thing that there's still no replacement for it. And they just added a method to define your own class in there, so they're adding new functionality in there, which is quite funny. So, and if you don't use that, you should be aware also of your dependencies using that. And the way you check that is there's a small software called JDEP that's going to scan your jar and tells you what you're using that you shouldn't be using. All right, other impactful change in Java 9. G1 becomes the default GC. Not everybody is going to be happy about that, because we're kind of used to CMS and all the different GC. G1's got a different latency profile, it's got different optimization strategies, so be aware that if you're running your application and you see some stop the world event happening at different stage, it's probably because G1 is running. So you can still use a previous CMS, although it's deprecated, so they're probably going to remove it in the next version. But it will have an impact. The other one is string compaction, and I put it there isolated because also it's going to reduce your memory footprint by encoding purely Latin 1 strings with a Latin 1 encoding. That comes with a higher CPU utilization, so that's been compensated by using a lot of intrasec, and the VM is generating better ASM code, but there's still some occasion where the switch between Latin 1 encoded string or UTF-16 encoded string might dominate the code. The string builder and string buffer have been changed to use byte array also under the hood, so the cost of building string might be more expensive. Is Java 9 all pen? Java 9 has 91 JEPs, so 91 change are planned. Most of them are maintenance JEPs, but there's a few goodies in there, and we'll try to go through. Compact string. So, I've talked a bit about that one. So there's no API change. Fundamentally, what is changing is that instead of storing the information in a char array, it's stored in a byte array. And there's another byte that tells it if it's Latin 1 or UTF-16. So as I said, it's better JIT and better intrasec to mitigate cost. But if you do, for example, an index off, a character, and if the character is at the beginning of the string, it's likely that you won't see any benefit from that. There's mixed results from those optimization. One thing that is funny though is that in Java 9, if you do a search of a character, if you pass a string, it would be faster than if you pass a character. Because the character version hasn't been doesn't have an optimized version, and the string one has. So, but I wouldn't optimize for that because there's a ticket for it to get sorted in Java 10. So there you go. You can disable compact string, but what you're doing is just making all your string being encoded in UTF-16. You're not reverting back to your char array. Probably the only people who would benefit from that would be people with a mix of UTF-16 and Latin 1 string that would make the check of the byte to check the encoding be non-predictable. So if most of your string are Latin 1, the CPU is going to be able to predict the branch on you, it'll be fine. But if you start to have 50-50, you might see a cost there that might be prejudicial. So you are able to disable the Latin 1 optimization. JShell. It's just a REPL. It's got auto completion. For all people like me, when I want to try something, I write a unit test or I write a pretty static vote main and I start writing in it and run it. Now we can do exploratory coding in JShell. It's available now. I don't think I will be using it because I'm too old and I've got my own habits, but I'm sure you guys will. AOT, so ahead of time compilation. So it's experimental and it works slightly differently. Azul has an ahead of time compilation that works differently. They capture the profiling information, and when you start, you can reuse the profiling information, and it's going to use that to then compile the Java bytecode to the native bytecode. The JEP 295 actually compile your class to SO files, but because there's no profiling information, it won't be able to do any optimization. There's a way to compile it with trigger to go back to the optimization cycle, so that once you capture profiling information, you go back into re-evaluating and do something. I would not use it yet. It's not available. On the server side, that's probably not useful. What it's going to give you is like an immediate start time, but with not very good performance. So be aware. Spin-weight int. That's the smallest JEP ever. That's basically thread.onSpinWeight. That's all that change. And that's basically very useful for people who do low latency thing. It's when you have a thread that just keep on looping and check for a value, and if that value changes, then you do something. So if you, for example, if you got a queue, and you got a queue consumer that keeps checking if there's something on the queue, and you want no latency, so you don't put any pause in there or anything. What happened is that on x86, once the field change, that there's a lot of instruction there that become invalid, and that create flushing of pipelines and all that kind of stuff that's costly. The onSpin weight will be directly translated to impose instruction that avoid that cost and also reduce your energy consumption. So if you use queues and you care about low latency, that one is for you. Stack Working API. I wrote an article about that. That's the only one I wrote. So it basically allows you to introspect what the current stack is. It's generally faster than Throwable, and because you can limit what you're going to go through, the cost of working the stack is proportional to the amount you're trying to capture. And also make available the getColor class, which was only available through the security manager at the minute. But if you're doing full traversal and access to the debug information, like the line number, just creating a throwable would be faster. They're talking about integrating that in logging frameworks to make it a lot faster, for example. That's probably the main target. The getColor class is useful for security checking. So if you want to make sure that the caller is somebody you know, you use that. There's more detail on the article. Go for it. var handles. So that one is very low level. So people who do a lot of low latency operation, what they like to do is like CAS operation, or they like to have volatile access. It is possible to do volatile access in Java, but it's not possible to do that on an element of an array, which is why everybody used unsafe. Var handles allow you to have a safe replacement for unsafe for those operations. So what you do is you get a variable on a variable of your class, and you can do volatile access, memory barriers, memory fence, all those things. You can do CAS operation on those. It's mainly used for low latency, again, or non-blocking code. So if you want to not use lock, which you shouldn't do, that's going to be very useful. And that one, there's a wee box there, as you can see. They added a search box in the Java doc, so now you can search for it. It's pretty awesome. So that's kind of the goodies. I mean, there's a few other things you can look. There's no big, it's not Java 8, there's no lambdas. It's mainly like a work for the fundamental, but it allows what's going to come next. And what's coming next, one thing that is interesting is Java 9 is the last release that we're going to release all those bunch of features together, and we release one that is ready. From Java 10, they use a release trend. So what is ready is going to ship, and what is not ready is not going to go in. So there'll be no more Jigsaw blocking everything. But to be able to do that, they need Jigsaw. So. There's some very interesting work coming in the next few years. Valhalla, which is basically the impression of value types. So that will allow you to have kind of structures, but not exactly structures. So it's like, instead of creating an object, you can have an array, for example, of structure like a point. So let's say a point is going to be a value type, so you get x, y. Currently what you have is an object, and each cell on the array points to the point where there's two fields with x, y. Value type allows you to have an array of x, y point, and they're continuously. So you basically can extend all the primitive types to be whatever. So we'll be also able to have unsigned types and do whatever you want. That involves a lot of change. They're changing the bytecode to be able to support that. And that complexifies the generic support, because obviously generic now assume that it's an object, so it's and generics don't support primitive types. Now that we're going to have value types and everybody's going to be able to create value types, they want to be able to have value types in generics. But because the current generic work with removing the generics information and using everything as an object, that's not going to work for value types. So they'll have it seems that they're going for a two strategy, which is keeping current object related things the same as they are with the erasure, and they're going to specialize classes that use primitive types, value types. So that should be quite fun. They're changing a lot of the bytecode to be able to support that. Panama, which is another interesting one, does anybody use JNI? No? Yeah. Good luck. So JNI is a pain. It's very hard to do, and also it's very costly. Once you go from Java to JNI, there's a barrier. So it does some check when you quit the Java world, and that's quite costly. So you can't, if you go, for example, to the spin white pose instruction, you could have called it in JNI, but because you need to cross the JNI Java boundary, every time, you basically, there's no benefits for it. So Panama is a new way to interact with native code, and it will allow you to do like ASM snippets. So you can write your assembly for a targeted stuff and to use it directly in your Java with no performance penalty. And Intel is already working on that, and they have a vectorization API to do single instruction, multiple data. So you'll be able to basically process, good. You'll be able to use like low-level instruction from the processor. Shadona, which looks a lot more promising than G1, which is an ultra-low pause time garbage collector. If you follow, there's a guy called Alexis Shipleft that worked on it, and he's got some very interesting results. That's probably the most promising thing happening in garbage collector world at the minute. And there's Graal, which is a new JIT compiler, which probably is going to replace C2. Graal is written in Java, so it's a lot more maintainable. And that's quite interesting. You know, what's interesting too is that you got Azul. Azul, they just released Falcon, and Falcon is using the LLVM compiler to generate the ASM. So there we can see like different strategies there. The advantage of using LLVM is you can leveraging all the LLVM open source project. But Graal is going to be quite interesting because C2 is showing quite a bit of a. It's very hard for people to add new intrinsic or change the behavior of it. One of the things I didn't talk in Java 9 is they're changing the way the string get concatenated when you use the plus argument because of the side effect of the string compressed string. There's an optimization in there that tried to optimize the way the string concatenation works, but it didn't work anymore, so they're rewriting it. I think that's it. Yeah, like that. Exciting. Any questions?
If I understand you correctly, just the way you phrased it, you said looked at Java 9 as just plain and Java 10 as not plain. Is that how you see it?
Yes. So Java 9 has a lot of impact due to Jigsaw on your code. So they minimize those impacts now. But in Java, they're probably going to change the flag for illegal access with Java 10. So there'll be a hit there that people are going to have to get ready for. But there's a lot more food for developers in Java 10 than there is in Java 9.
Will Java 9 cause any problems interacting with code that currently uses OSGI?
It shouldn't, no. The only thing is that they won't be able to leverage a module system. They'll need to keep using their own class loader hierarchy. They would like to use the module system, which is what those big debates were about. But no. The only problem is reflection, but that's been addressed. And there comes some MISC APIs, but OSGI probably doesn't use any. So. Oh, and Java 9 is faster, by the way, if you're on it. It's slightly faster. All right. All right, thank you.